Hello and welcome back to another video. In this problem, we're given 4 graphs, and we're asked which of the graphs below illustrates a strong positive correlation between h and p. So we have h on the y-axis and p on the x-axis. And for it to be a positive correlation, that means as one variable increases, the other increases. A negative correlation would be as one variable increases, the other decreases. So which of these is both of the variables increasing at the same time? So p is on the x-axis, so we're going to be looking left to right to look for p to be increasing. And we're looking, okay, which of these is h increasing as we look left to right? So in this first one, we have, it starts down here, and then h, the y value, increases as we go. So far A is good. We still have to worry about a strong correlation, but right now it's positive, so it's good. In B, the value of h starts up here, and then it goes down and it decreases. So B is not a positive correlation. C, as we go, there isn't really a range of P, right? It's all bunched in this little area right here on when thinking in terms of P. So we can't say, okay, as P increases, does h increase or decrease? There's a small range of P values, and h is spread out through all of them. So there isn't any correlation, positive or negative. And then for D, as P increases, h stays the same. So it's also not D. So A is the only positive correlation. So we don't even have to worry about the fact that there isn't a strong correlation or a weak correlation. An example of a weak correlation would be if we have a similar graph and both of the variables are increasing at the same time, but the data is a lot more spread out, right? Versus here, it's really bunched up. If it's really spread out, that's a weak correlation. Here, it's a strong correlation, but it's kind of the only one, so it doesn't even matter. A is going to be your final answer either way. As always, thank you for liking and subscribing, and I'll see you in the next video.